You can trust China to surprise the world with futuristic innovations, but this time, it is dominating even the wheels department. Across the country, engineers are building machines that float on water, fly above traffic, climb into the sky, and even drive themselves without a steering wheel. At the same time, the United States is racing to keep up, developing its own next-generation engines, electric motors, and flying vehicles. This is more than a battle of brands. It is a technological race that will shape how the world moves in the next decade. We begin with one of the wildest Chinese creations on the road today, the BYD Yangwang U8. At first glance, it looks like a luxury SUV, but hidden beneath its body is a sophisticated hydraulic suspension and advanced control system. The vehicle can raise or lower itself by about 150 millimeters, giving it impressive ground clearance for rough roads and off-road terrain. It can even perform a tank turn, spinning a full 360 degrees in place, a feature that makes parking and tight maneuvers look like a futuristic stunt. What truly sets the Yangwang U8 apart is its emergency floating mode. In situations like sudden floods or waterlogged streets, the vehicle detects the danger and activates a special survival configuration. The engine shuts down, the suspension seals itself, the windows close, the air conditioning stays on, and the sunroof can open as a potential escape route. In this mode, the SUV can float in water for up to 30 minutes and move at around 3 kilometers per hour. The standard model can handle water a meter deep, while the off-road version can manage depths of 1.5 meters. It is not a toy for lake vacations, and it needs a service check afterward. But it shows how far Chinese automakers are pushing the definition of what an SUV can do. On rails instead of wheels, China has built the so-called Sky Train, an unmanned, suspended monorail that glides above the city landscape like something out of a science fiction movie. The line stretches about 10.5 kilometers and carries up to 200 passengers at a speed of 60 kilometers per hour. Unlike a traditional train buried in tunnels or stuck at ground level with traffic, this system floats above congestion, using pillars and a slim track. Construction took only about 7 months, roughly the same time needed to lay conventional track. But the benefits are greater capacity, fewer accidents, and more free space at ground level for parks, roads, or buildings. It is a practical demonstration that urban transit can be fast to build, efficient to run, and futuristic to experience. In the skies, the EHang 216S takes urban air mobility to a new level. This passenger drone looks like a compact multi-rotor aircraft with 8 arms, each holding a pair of electric rotors. It carries 2 passengers in a closed cabin and is designed for short to medium city hops. What makes it remarkable is its full autonomy. There is no pilot stick, no need for passenger control. The onboard flight computer manages takeoff, route navigation, obstacle avoidance, and landing. Safety systems are built so that even if one rotor fails, the aircraft can still complete its flight and land safely. With a top speed of about 130 kilometers per hour and an operational ceiling of roughly 3,000 meters, it offers a glimpse of how air taxis could move people quietly and cleanly over crowded streets. Back on the ground, NIO's ET9 sedan showcases a different kind of innovation. This luxury electric flagship attracted attention for its ability to shake snow off its roof, using an advanced chassis and hydraulic suspension. In demonstrations, the car rocked itself side to side, imitating a dog shaking off water, sending snow sliding to the ground without the driver ever touching a brush. Of course, anything loose in the cabin, like a coffee cup, might pay the price during this dramatic motion. Beneath the elegance, the ET9 uses a powerful dual-motor drivetrain and a large battery pack of around 120 kilowatt-hours, providing both strong performance and an impressive driving range. Fast charging technology allows the car to add significant range in just a few minutes, reinforcing China's reputation in high-end electric vehicles. Innovation is not coming only from China. Around the world, engineers are experimenting with vehicles that seem to blur the line between car, motorcycle, and aircraft. The Lazareth LMV 496, developed in France, is one of the most extreme examples. On the road, it acts as an electric motorcycle with a range suitable for city cruising. But, with the flip of a switch, its four wheels tilt outwards and reveal jet turbines hidden inside the hubs. These kerosene-powered turbines generate an astonishing amount of thrust, reportedly around 1,300 horsepower, allowing the bike to lift off vertically and hover for several minutes. Flight time is short, around 10 minutes, and the machine is extremely expensive, but as a concept, it shows what happens when personal transportation merges with jet technology and vertical takeoff and landing principles. China's ambition extends into the domain of flying cars as well. At a recent technology showcase, GAC presented the Gove, a futuristic concept that combines a ground vehicle chassis with a detachable aerial module. The lower section functions like an electric car, moving through city streets on four wheels. Mounted on top is a capsule that can detach and rise into the air as a drone, equipped with multiple folding rotors. The system is designed to operate autonomously. A passenger inputs a destination on a tablet screen, and the vehicle, whether rolling or flying, calculates the route, avoids obstacles, and can even navigate to a charging station on its own when energy runs low. On the road, it behaves like a compact urban electric vehicle. In the air, it offers a direct path above traffic. Another vision of the future is the Flyer, an electric vertical takeoff and landing aircraft created for personal recreation and urban mobility. It rises straight up, hovers, and moves forward without the need for a runway. Flight regulations are still catching up to these new machines, but the Flyer and similar craft show how eVTOL technology can turn everyday city commutes into short flights above congestion. They rely on multiple electric rotors, redundant systems, and intuitive controls so that even people without traditional pilot training may one day be able to use them safely. On the ground, autonomy is advancing quickly. Zoox, a company backed by Amazon, has developed a fully autonomous robotaxi with a completely symmetrical design. There is no front or rear in the traditional sense. The vehicle can move in either direction without turning around. Inside, 4 passengers sit facing each other in a spacious cabin with no steering wheel or driver's seat. Sensors, including LiDAR, cameras, and radar, provide a 360-degree view of the surroundings. The electric drivetrain allows the vehicle to reach speeds of up to 75 miles per hour and operate for as long as 16 hours on a single charge. Rather than selling these cars to individuals, the company plans to offer a ride-hailing service, positioning the robo-taxi as a shared, efficient, and constantly available urban mobility solution. Japan brings its own creativity to urban mobility with the Raptor platform from Roids Tech. This 3-wheeled vehicle consists of a lower base block and an upper design unit that can be attached or removed depending on the use case. Powered by a 48-volt battery, it reaches speeds around 30 kilometers per hour and offers a range of roughly 40 kilometers. Legally, it is treated like a motor-assisted bicycle and requires a driver's license, but its modular construction suggests potential for new business models, from delivery services to customizable personal transport. The company imagines it as a tool not just for commuting, but for reshaping urban culture and infrastructure. Behind these headline-grabbing machines lies a deeper story about strategy and national ambition. China is not just building eye-catching prototypes for short clips. It is investing heavily in research centers, battery factories, software platforms, and test corridors where these vehicles can be tried in real conditions. Entire districts are being planned around smart mobility, with charging stations, dedicated lanes, and integrated data systems. Every successful launch is both a technological achievement and a signal to the world that China intends to be at the front of the mobility revolution. At the same time, the United States is closely watching these developments while pushing forward its own strengths in software, artificial intelligence, aerospace engineering, and high-performance electric powertrains. In Silicon Valley and other innovation hubs, startups and established manufacturers are building the next generations of motors, inverters, hydrogen stacks, and hybrid engines. Where China often focuses on scale and rapid deployment, American companies tend to emphasize cutting-edge performance, autonomy algorithms, and premium user experience. The result is a global competition that constantly raises the bar for what vehicles can do. For everyday people, this race is more than geopolitical. It determines whether your next car can drive itself in traffic, whether your city will add a suspended train or a drone taxi route, and how quickly emergency vehicles or deliveries can reach you in a crisis. It defines how much noise, pollution, and time the world will continue to sacrifice for basic transportation, and how soon cleaner and smarter alternatives will become mainstream. As we move into the next chapter of this story, the question is no longer whether mobility will change, but how quickly and which technologies will define the new normal. In many ways, these early vehicles and systems feel like the first generation of the smartphone era, when touchscreens, apps, and mobile internet were still new and slightly experimental. Today's floating SUVs, autonomous robo-taxis, and personal eVTOLs may seem exotic, expensive, or limited to test zones, but they lay the groundwork for more refined, widely available versions that will follow. As manufacturing costs drop, batteries improve, and regulations adapt, the technologies you are seeing now in headlines and demonstrations may soon appear in ordinary neighborhoods, turning science fiction into part of daily life. Around the world, a new generation of mobility inventions is blurring the lines between vehicles, robots, and wearable technology. They are not just about getting from point A to point B, but about changing how we live, work, and feel while moving. After looking at floating SUVs, flying cars, and autonomous taxis, we now step into an even stranger frontier, where machines can follow you like a pet, transform under your feet, or react to your emotions. One of the most charming examples of this future is the Ridroid Kanguro, developed in Japan by engineers from the University of Tokyo and the Advanced Technology Center for Robotics. At first sight, Kanguro looks like a compact robotic assistant on 3 wheels, but it can play 2 very different roles. In assistant mode, it follows its owner around, carrying bags, groceries, or equipment like a smart robotic companion. With advanced mapping and positioning systems, it learns environments, avoids obstacles, and navigates through crowded spaces. Then, with a simple command, it transforms into a rideable vehicle similar to a futuristic scooter or Segway. In this mode, the user can sit or stand and travel at speeds of up to 10 kilometers per hour. Sensors and control software ensure that if the rider loses balance or an object appears suddenly, Kanguro can intervene and steer safely around danger. It is part personal robot, part micro vehicle, and it hints at a future in which mobility devices become more like interactive partners than passive machines. China's Xpeng Aero HT brings another level of ambition with the Xpeng X3, a flying car that combines road practicality with vertical takeoff capabilities. Weighing close to 2,000 kilograms, the X3 integrates an electric vehicle chassis with an 8-rotor flight system. On the street, it behaves like a conventional car, allowing the driver to navigate traffic in a familiar way. When the time comes to fly, the vehicle transitions into aerial mode, deploying its rotors and lifting straight up from the ground. Control is designed to remain intuitive, using a steering wheel and a simple set of commands rather than complex pilot controls. The X3 can reach about 130 kilometers per hour in the air and remain aloft for roughly 35 minutes, making it suitable for short hops between nearby cities, islands, or remote areas. A clever feature is its ground module recharging the air module, minimizing downtime and increasing flexibility. Together, these systems present a serious attempt to turn the idea of flying cars into something concrete and testable. In the field of emergency response and fast access, the Jump Aero JA-1 is another electric vertical takeoff and landing aircraft with a very specific mission. Unlike recreational eVTOLs designed to please tourists or commuters, the JA-1 focuses on getting first responders to critical incidents as quickly as possible. Its compact frame, electric propulsion, and high speed allow it to reach places that might take far longer to access by road, especially in rural or congested areas. The vision is simple, but powerful. When every minute counts, a rapid, quiet, and emission-free aircraft could mean the difference between life and death. The JA-1 thus represents a different side of advanced mobility, one where technology is not just exciting, but directly tied to saving lives. On the ground, concept vehicles like the Shane electric car, created by Shane Chen, the inventor of the original hoverboard, show how radical design can challenge our expectations of what a car should look like. The Shane uses only 2 large wheels, mounted on the sides of a capsule-like cabin, yet it is engineered to carry up to 5 adults. At first glance, it resembles a ride from a futuristic amusement park. But behind the playful image lies serious stability engineering. The wheels and control system continuously adjust to keep the vehicle balanced, even at higher speeds. By shifting the center of gravity and using precise control of acceleration and braking, the Shane aims to offer the safety of a traditional 4-wheeled car on just 2 wheels. It suggests a future where unusual, almost toy-like shapes might hide highly advanced physics and control algorithms. Toyota's concept iWalk takes a different approach to future mobility, focusing on short-distance travel in dense urban spaces. Instead of replacing the car, it aims to replace short walks, slow shuttles, and uncomfortable last-mile trips. The iWalk is a 3-wheeled, standing mobility device with an electric motor and a joystick for steering. Its range of 10 to 20 kilometers and a top speed suited for sidewalks and pedestrian areas make it ideal for moving through shopping districts, campuses, airports, or city centers without breaking a sweat. As the speed increases, the base extends and adjusts to improve stability. Because it is easier to control than a hoverboard and less demanding than a bike, it could appeal to elderly users or people with limited mobility, offering independence without the complexity of a full-sized vehicle. Honda's Moto Compacto explores yet another dimension of urban mobility: portability. This tiny electric scooter folds into a rectangular shape not much larger than a suitcase. When folded, it can slide into the trunk of a car, be carried upstairs, or stored under a desk. Unfolded, it becomes a simple electric 2-wheeler, capable of short trips at around 20 to 24 kilometers per hour, and a range suited for daily commuting in town. With a weight under 20 kilograms and a charge time of only a few hours, it captures the idea that in crowded cities, the ability to fold and carry your vehicle can be as valuable as speed or luxury. It is designed not for long distances, but for those last few kilometers between a train station, a bus stop, and home or work. At the more experimental end of the spectrum lies Yamaha's Motoroid, a concept motorcycle that behaves more like a living entity than a machine. Motoroid incorporates self-balancing technology, allowing it to remain upright even when not held by a rider. It can roll forward to greet its owner, recognize their face, and respond to simple gestures. Haptic feedback systems and advanced sensors let it interpret body movements and adjust accordingly, creating a more intuitive and emotional connection between rider and bike. It can also project information into the rider's field of view, reducing the need to look down at traditional instrument panels. The message is clear. In the coming decades, vehicles may not just transport us. They may interact with us, learn from us, and adapt to our style in ways that feel almost like companionship. Honda is also exploring deeper integration of digital layers into mobility through extended reality experiences. By combining augmented reality and virtual reality technologies with driving, navigation, and in-car entertainment, Honda imagines vehicles that can overlay useful information directly onto the world outside the windshield. Drivers could see real-time navigation cues aligned with the road, receive hazard warnings before they are obvious to the eye, or discover points of interest highlighted in context. Passengers might enter virtual worlds during long trips, play immersive games, or undergo realistic training simulations without leaving their seats. These systems are supported by advanced driver assistance technologies in the background, ensuring that while the digital experience becomes richer, safety remains paramount. The result is a vision of mobility, where the physical and virtual worlds blend, turning the cabin into both a vehicle and an experience space. It is not only land and air that are changing. On water, Slovenian engineer David Vukovic has developed the hydrofoil jet ski Flyway, an electric jet ski that uses hydrofoils to lift the hull above the surface of the water. By reducing contact with the water, hydrofoils cut resistance dramatically, allowing the Flyway to reach high speeds, reportedly up to 88 kilometers per hour, while maintaining a smooth, gliding feel. With a potential range around 100 kilometers per charge, it offers both performance and endurance. Because it is electric, it operates quietly and produces no direct emissions, making it attractive for lakes, coastal areas, and marine parks where noise and pollution are growing concerns. The Flyway shows how fun, high-adrenaline water sports can also align with sustainability. On a single wheel instead of two, the InMotion 514 electric unicycle pushes the limits of compact personal transportation. Designed for experienced riders, it can reach astonishing speeds, well above typical scooter limits, and handle steep inclines up to 50 degrees. Its rugged construction and advanced control algorithms allow it to traverse not only smooth pavement, but also gravel and dirt paths, expanding where a minimalist vehicle can go. Compared to a traditional bicycle, the V14 takes up very little storage space while delivering a powerful, intense riding experience. It embodies a certain philosophy that the future of personal transport might not always mean bigger, but smarter, more agile, and more extreme. Taken together, these machines illustrate an important trend. The future of mobility is not just about replacing gasoline cars with electric ones. It is about rethinking the very shapes, sizes, and roles of vehicles in our lives. Some devices will follow us, like assistants. Some will fold into our luggage. Some will hover above traffic, and others will merge physical travel with digital immersion. Behind each of these vehicles is a network of suppliers, software developers, battery engineers, and regulatory experts working to turn bold ideas into safe, certifiable products. Autonomous navigation systems must be trained on countless scenarios, from crowded sidewalks and chaotic intersections to sudden weather changes and technical failures. Battery packs must balance weight, capacity, charging speed, and safety. Human-machine interfaces must be designed so that beginners can learn quickly without feeling overwhelmed. Even something as playful as a folding scooter or a robotic assistant involves deep questions about liability, infrastructure, and digital security. Cities, too, will have to adapt. Sidewalks may one day host a mix of pedestrians, delivery robots, and small rideable platforms. Skies above major metropolitan areas could carry air taxis, emergency eVTOLs, and cargo drones. Harbors might see quiet hydrofoil craft instead of roaring gasoline engines. This transformation will require new rules about air corridors, charging stations, data handling, and shared spaces. Yet, if managed well, it could also reduce congestion, cut emissions, and return valuable land from parking lots and wide roads back to homes, parks, and natural spaces. As you think about these machines, it is worth asking which of them feels most likely to enter your own life. Would you trust a flying car to carry you above a city? Would you ride a motorcycle that can balance itself and understand your gestures? Would you welcome a small robot that follows you around and offers a ride when you are tired? The answers to these questions will guide not only companies and engineers, but also governments and citizens as they decide what kind of mobility future they want to build. In the next and final part of this journey, we will zoom out to look at how China and the United States are competing to lead this transformation, and how their new engines, propulsion systems, and infrastructure investments will affect the entire planet. As we move deeper into the era of intelligent transportation, mobility is no longer limited to personal cars, scooters, or flying taxis. Entire fleets of specialized vehicles are being designed to keep cities running smoothly, from autonomous shuttles to next-generation fire engines. These machines may not look as glamorous as flying bikes or folding scooters, but they are essential for making future cities safer, cleaner, and more efficient. One example is Origo's family of autonomous pods. These compact electric vehicles are built to operate without a driver in complex environments such as airports, downtown streets, university campuses, and industrial zones. Each pod is equipped with a dense array of sensors, including LiDAR, radar, and high-resolution cameras, along with powerful onboard computers running advanced artificial intelligence software. This combination allows the pods to map their surroundings in 3 dimensions, detect pedestrians, vehicles, and obstacles, and plan safe paths at low to moderate speeds. They can be configured for many different roles, carrying passengers like a small shuttle bus, transporting packages as a mobile delivery van, or even acting as a mobile shop or information kiosk. Because they run on electricity and can be coordinated by a central control platform, fleets of these pods promise to reduce emissions, cut noise, and provide highly flexible transport services in busy urban centers. In critical situations, specialized vehicles like the Rosenbauer RT fire engine show how advanced technology can save lives while reducing environmental impact. Traditional fire trucks are loud, heavy, and powered entirely by combustion engines. The RT, developed by the Austrian company Rosenbauer, uses a hybrid powertrain with a high-voltage battery system at its core. For many operations, the truck can drive and run its pumps on electric power alone, dramatically cutting noise and exhaust fumes at the scene of an emergency. This is especially important in dense cities and in enclosed areas such as tunnels, underground garages, or large buildings, where smoke and fumes are already a challenge. The RT's design is compact and highly maneuverable, with a low center of gravity and adjustable suspension that makes it easier to navigate tight streets. Its layout lets firefighters access tools and hoses quickly, reducing response times when every second counts. In this way, the RT is more than a fire truck. It is a response to urbanization, climate concerns, and the demanding work of modern emergency services. When we zoom out from individual machines, a bigger picture emerges. The race between China and the United States in mobility technology is part of a larger technological and economic rivalry. Both countries see transportation as a strategic field that influences energy use, national security, industrial strength, and global influence. They are not only competing to sell cars or aircraft, they are also vying to set standards, build ecosystems, and control key supply chains. China has become a giant in electric vehicle production, supported by strong government incentives, extensive charging infrastructure, and a huge domestic market. Companies like BYD, NIO, XPeng, and others are building electric cars, buses, and trucks in massive volumes. Firms such as EHang and AeroHT are working on passenger drones and flying cars, while high-speed rail networks and experimental systems like the SkyTrain expand public transportation capacity. China's strategy emphasizes scale, affordability, and rapid rollout. By producing large numbers of vehicles and building dense networks of chargers and rail lines, it aims to dominate both domestic and global markets with cost-effective, reliable mobility solutions. The United States, meanwhile, has its own strengths. It is home to pioneering companies like Tesla and Rivian in the electric vehicle space, as well as major legacy automakers such as General Motors and Ford that are rapidly electrifying their lineups. American firms are leaders in high-performance electric motors, battery management software, and advanced driver assistance systems. In the aerospace sector, companies like Boeing and SpaceX are pushing forward with more efficient engines, reusable rockets, and aircraft that can use sustainable aviation fuels. Startups and defense contractors are experimenting with hybrid electric propulsion for drones and aircraft, seeking longer range, lower noise, and improved stealth capabilities. The United States also invests heavily in artificial intelligence and cloud computing, which feed into autonomous driving platforms, traffic optimization systems, and predictive maintenance for vehicles and infrastructure. Looking ahead to engines and propulsion systems expected around 2025 and beyond, American automakers and aerospace companies are working on several fronts at once. In electric vehicles, new motor designs aim to increase power density, reduce the use of rare materials, and improve efficiency at highway speeds. Battery technology is evolving toward higher energy density cells, faster charging, and better thermal management, making long-distance electric travel more convenient. Hydrogen fuel cells and hydrogen combustion engines are being explored for heavy trucks, buses, and some aircraft, where batteries alone may be too heavy or slow to recharge. Hybrid systems that combine batteries with hydrogen or efficient combustion engines are also under development, seeking to deliver strong performance while significantly cutting emissions. In aviation, sustainable aviation fuels derived from biological sources, captured carbon, or synthetic processes promise to reduce the carbon footprint of existing jet engines without requiring a complete redesign of the global aircraft fleet. At the same time, new concepts for hybrid electric regional aircraft could shorten routes, link smaller cities more efficiently, and reduce noise around airports. Space launch companies are refining reusable rockets to lower the cost of reaching orbit, which in turn supports communications networks, satellite navigation, and Earth observation systems that benefit transportation on the ground and in the air. China is not standing still in these areas. Its researchers and manufacturers are investing in solid-state batteries, high-efficiency electric drivetrains, hydrogen technologies, and their own variations of sustainable fuels. High-speed rail continues to expand, and proposals for ultra-fast magnetic levitation lines show how seriously the country takes long-distance, low-carbon transport. Chinese cities are also rolling out smart traffic management platforms that integrate cameras, sensors, and artificial intelligence to coordinate traffic lights, public transit, and emergency vehicles. When combined with domestic production of batteries, rare earth magnets, and electronics, these efforts give China a powerful position in the global mobility supply chain. For the rest of the world, this intense competition brings both opportunities and challenges. On the one hand, innovation accelerates. Consumers gain access to better vehicles, cleaner buses and trains, and more advanced safety features faster than they would if only one country drove the pace of change. On the other hand, nations must decide how to build their own infrastructure, where to source critical components, and how much they want to rely on foreign technology for essential systems such as transportation, energy, and communication. Questions about data security, privacy, and dependence on imported hardware become more urgent when vehicles themselves are connected, autonomous, and constantly exchanging information with remote servers. At a human level, the transformation of mobility raises more personal questions. As cars learn to drive themselves, will people still enjoy being behind the wheel? Or will they prefer to relax, work, or watch content while an algorithm handles the road? If flying taxis and personal eVTOLs become safe and affordable, will we redesign cities to include skyports and vertical corridors? Or will fears about noise and visual clutter slow their adoption? If small robots can deliver groceries, escort children, or assist elderly people, how will that affect local jobs, neighborhood life, and our sense of community? One thing is clear: the engines, batteries, and vehicles now in development are not just technical projects. They are choices about how we want to live, how we want to use resources, and how we want to move through the world. China's focus on massive deployment and integrated planning, and the United States' focus on high-end innovation and software-driven ecosystems represent two powerful, sometimes competing visions of that future. Other regions, from Europe to Japan to emerging economies, will also bring their own priorities and ideas, from strict environmental standards to human-centered design and public transit expansion. As these trends unfold, we are witnessing the early stages of a global mobility revolution. Floating SUVs that can survive floods, trains that glide above city streets, robots that carry you through a crowd, flying cars with vertical takeoff, quiet hydrofoil jet skis, and intelligent fire engines are not isolated curiosities. They are signals that transportation is entering a new phase, driven by electricity, automation, connectivity, and creativity. Whether you live in a megacity, a small town, or a remote region, the decisions being made today in research labs, design studios, and government offices will shape how you travel tomorrow. The race between nations may make the headlines, but the real winners or losers will be ordinary people and the planet itself. If these innovations are guided wisely, they can reduce emissions, save time, improve safety, and open up new possibilities for work, leisure, and exploration. If they are guided poorly, they could deepen inequalities, increase surveillance, or lock societies into fragile systems. The story is still being written. For now, we stand at the beginning of this transformation, watching prototypes roll, float, and fly into the world. The next time you see a new vehicle go viral on your screen, whether it is a floating car in China, a self-driving taxi in an American city, or a tiny scooter unfolding on a crowded sidewalk, remember that you are not just looking at a gadget. You are looking at a piece of the future of mobility, and the choices we make today will determine what that future feels like for all of us. In the end, the question is not whether China or the United States will win some abstract competition, but how humanity as a whole can benefit from this surge of creativity without repeating the mistakes of the past. Cleaner engines and smarter vehicles will matter only if the electricity that powers them comes from sustainable sources. If cities are designed to be livable and inclusive, and if people everywhere can afford to take part in the new mobility era. The technologies are arriving quickly. Now the world must decide how to use them wisely, so that innovation on wheels, wings, and hydrofoils truly moves us all forward.